Plate Motion Unit, Lesson 3.1, Considering Rates of Plate Movement. Activity 2, Observe how plates move. Here's what your student screen looks like for this part of the lesson. Chapter 3 question, how did the Mesosaurus fossils on the South American plate and African plate get so far apart? We know that the plate boundary between the South American plate and African plate is a divergent plate boundary, a boundary where plates move away from each other. This movement separated the Mesosaurus fossils. Remember, these are the claims about the plate boundary between the South American plate and African plate that we are investigating for the Museum of West Namibia. Claim 1, the South American plate and African plate moved apart suddenly. Claim 2, the South American plate and African plate moved apart gradually. Specifically, the museum wants to know whether the fossils were separated by slow plate movement that took a long time or sudden plate movement that made the fossils move apart very quickly. In this lesson and the lessons that follow, you will collect evidence to answer the Chapter 3 question, beginning with an investigation of how the plates are moving today, in the present time. Today, we will investigate this question. What do we know about plate motion that is currently taking place? In today's lesson, we will begin to determine how the plates with the Mesosaurus fossils move so far apart. Knowing about what is happening with plate motion today might help us get ideas about what may have been happening with plate motion in the past. Geologists believe that much of what we see happening in Earth's system today was also happening in the past in a similar way. So they use what we can observe today as evidence to explain what happened a very long time ago. We've learned that Earth's plates move. How fast do you think the plate below us is moving? In which direction is it moving? It is important to know that it's hard to tell exactly how the plate is moving because we aren't aware of this movement in our everyday lives. The only indicators of plate motion we can experience are earthquakes or volcanic activity, and those do not happen every day, or perhaps at all, depending on your geographic location. We're going to watch a video about how geologists use GPS, a technology that many of you may have used in your daily lives. What do you know about GPS? Where have you heard of GPS? Students, play the video. Plate movement map. Here is the plate movement map. In the video, we learned that GPS receivers on Earth can accurately measure the small distances that plates currently move, even though we humans cannot directly sense this movement. Since the 1970s, scientists have used measurements from GPS taken over a period of time to calculate the rate of plate motion. The video showed us that with GPS, scientists can calculate the rate at which an individual plate moves. Another way we can use GPS data to think about the rate of plate motion is to calculate how fast or slow the two plates are moving together or apart, as shown in the map. What do you notice about the current rate of plate motion at different boundaries on Earth? You might respond, this map shows that Earth's plates move at a very slow rate, usually between 1 and 10 centimeters per year. Here's what your student screen looks like for this part of the lesson. Vocabulary. Rate. How often or fast something happens. Remember to look at the glossary if you need more support. The rate of a car traveling can be measured in kilometers per hour. A heart rate can be measured in beats per minute. Let's think about how GPS data helps us answer the investigation question. From the video and the plate movement map, what can you say about the plate motion that is taking place right now, thanks to GPS data? Think about the investigation question. What do we know about plate motion that is currently taking place? You might respond, Earth plates move at an average rate of only a few centimeters per year. GPS data tells us that Earth plates move at an average rate of only a few centimeters per year. What we don't know is if the plates move at similar rates over longer periods of time. Here's what your student screen looks like for this part of the lesson. The sim allows us to observe a model of a plate motion happening over millions of years. Today, we'll use the sim to measure how far apart two plates move over long periods of time. Then we will calculate the rate of plate motion over millions of years using our data from the sim and compare our rates to the rates of plate motion happening today. When we compared calculated data used in the sim to rates of plate motion happening today, we'll look for patterns. Patterns and rates of change can provide evidence about natural systems such as the systems of Earth plates. We've been using patterns to think about evidence in maps And this is another way we can use the cross-cutting concept of patterns. Now, let's look at how to measure distances in the sim. Students, option 1, review the sim on the next slide using the description in the notes. Then skip the slide with the video demonstration, or skip the next slide and watch the video demonstration. Option 1, open the plate motion sim and use its features as follows. Open region 2 and notice the markers labeled 1, 2, and 3 on the right side of the screen. Drag 2 of the markers onto the map view, 1 on each side of the plate boundary. Place the markers so that they are as close as possible to each other and to the plate boundary. Set the plate boundary type to divergent and press Run. Notice the blue dashed lines that indicate the path of the markers. Pause the sim and press on a marker. Notice that the readout shows both the distance the selected marker has traveled and the distance from the selected marker to other markers on the screen. Option 2. If you did not conduct the live demonstration, play the video. To calculate the rate that plates are moving, we'll need to measure how far apart they moved after millions of years and then divide that distance by the number of years. It's not really possible to get the two markers in the sim model to be exactly at the same spot. This means there's a little bit of distance between the two markers to start with, so our calculations won't be completely accurate. However, we can try to get the markers as close together as possible. Our measurements in the sim will still give us a good estimate to understand the rate that the plates move apart over time. You are encouraged to use a calculator. Once you've calculated the rate of motion for each pair of distances and times, you will record your numbers in the rate column of your data table. Students, open the sim. What were your findings about the distance the plates moved over time? How far did the plates travel over 50, 100, 150, and 200 million years? Students, it's important to note the connection this measurement has to rate. That the rate is so slow, you had to run the sim for a long period of time to see significant plate movements. What did you calculate for the rate of plate motion? You should have found that the plates move at a rate of about 20 to 22 kilometers per million years, and this was constant for each time period. You may find slightly different rates depending on your precision when using the measuring tool. The divergent plates in region 2 of the sim move at a constant rate. We can consider this rate in the context of our own lives. Let's think of something that's about 20 kilometers or 12.4 miles away from your school. How long would it take to walk there? How long would it take plates to move that far apart? Think of a recognizable landmark that is about 20 kilometers away from your school. Note that it might seem pretty far away to you at the pace that you walk. It would take two plates over 1 million years to move this distance apart from each other. The sim allows us to see how plates move great distances over millions of years. We would not be able to observe this movement in our lifetimes. The sim helps us understand the rate of plate motion, even though we don't feel the plates moving. Plate movement map. The rate of plate motion you calculated in the sim, about 22 kilometers per million years, is equal to about 2 centimeters of movement per year. Compare the rate you calculated with the data from the sim to the rates on the plate movement map. Can you find a plate boundary on Earth with a rate of plate motion similar to the one you calculated with data from the sim? What does that tell you about the accuracy of the sim as a model? Remember, this sim is a model. Geologists use what's happening now to think about what happened in the past. Do we have evidence that plates are moving the same way today as they did in the past? We'll read about that in the next lesson. End of activity. Be sure to complete all your student work in Amplify for this activity before moving on.